So the practical aspect of linear programming, integer programming, is centered on the fixed charge. The fixed charge is just one of the applications. There is an employee scheduling and capital budgeting, and as I indicated, you watch these on the notes and then learn them yourself, okay? But I'm going to take you through the fixed charge. And for you to be able to appreciate this fixed charge story, I want to take you back a little bit to microeconomics theory. Microeconomics, okay? Let me remind you something you already know. That is if you know, okay? Microeconomics, there's something we learn in microeconomics which is known as the production theory and the cost theory. Let me just remind you of the cost theory, okay? Just the cost theory, remember this. And it's something that you might remember, okay? We have this line, which is a cost curve, and then we have another line, which is what do you call it? The quantity, okay, that is produced, the section there. And so on the y-axis, you have the cost. And then on the x-axis, you have the kill, okay, in small letters. And we have that kind of a cost which changes with the level of production. We have some costs that change with the level of production. Now, such a cost is usually called, if you can remember very carefully, it's usually called the variable cost. Do you remember the variable cost? The variable cost. So as the cost is rising, as the production is increasing, the cost will be rising. As the production is increasing, cost will be rising. This is a variable cost. It changes with the level of production. Now, this variable cost is something, if you were to bring it to linear programming, it would be something like 20x1. Okay, so that cost will be like that. So anytime x is increasing, or the x1 is increasing, that cost will be rising with it. Okay, that's production variable cost. But there's another kind of cost. There's another beautiful kind of cost. And I know some of you might remember this cost. And the name of this cost is known as a fixed cost. Okay? A fixed cost is that kind of a cost which is independent of the level of production. So let's say that cost is 100 cedis. It doesn't matter how much you produce, from 10 to 30 to 50, that cost is still fixed at 100. It doesn't change with the level of production. Okay? It doesn't change with the level of production. This fixed cost is what is known as the fixed charge in this integer programming we're about to do. The fixed charge is the cost that is already borne, is already incurred. Okay? I'll give you an example. Let's say that you want to do the production of some shoes, and then you go and actually buy or rent a big warehouse. And then you started doing that production, and all of a sudden, 2 days, everything, you know, the rain or the flood or fire engulfed the entire edifice and then brought it to zero. Everything is gone. Now that cost you already incurred, is gone already. It's fixed, it's incurred, it's borne. And that is a fixed charge. That is a fixed cost. And it is this principle of fixed cost that we are going to, you know, draw some information from. So in reality, whenever we talk about total cost in economics, and I want you to remember that, total cost is actually the fixed cost plus total cost is actually the fixed cost plus the variable cost. That is total cost. Okay, it's a fixed cost plus a variable cost. But you guys will remember, okay, there's no question, you remember that the actual profit of a firm, let me call it pi here, okay, the actual profit of a company is equal to profit is the total revenue minus the total cost. Do you remember? Do you remember? Exactly. Total revenue minus total cost. That is it. But now we are telling you that this total cost is actually made up of what? It's made up of the fixed cost plus the variable cost. Have this backup, flashback learning into your mind as we are about to embark on a beautiful, beautiful, beautiful assignment right here. Because with this understanding, you are ready to rock and roll. So we are going to use this principle of fixed charge to learn something incredible, ladies and gentlemen. Very, very incredible. Okay. So I'm going to show you how you can bring the principle of fixed charge right here. Okay. And then how we will understand the economics ambience. And to do that, I'm going to take a typical real life example, Tema Textile Limited. And I want you to pay attention, focus your entire mind, head to toe, your entire cerebrum, and cerebral cortex, and walk with me in this beautiful journey. This company manufactures 3 types of clothing: shirts, shorts, pants. Now, the manufacturing of each type of these clothes, okay, the manufacturing of each one of them requires that the company TTL has suitable type of machinery available. Now that sentence, suitable type of machinery available, is an important word. You've got to have it available. The machinery needed to produce each type of clothing must be rented at the following rate. Now I want you to please understand something small. The first thing is this: you are going to produce shirts, shorts, and pants, but you need shirt machinery, which will cost $200, 200 cedis a week. You need that to be there before you can produce what? The shirts. You need 150 cedis machinery cost for short machinery to be there. So this machinery has to be there before you even think about producing the shorts. The pant machinery, you got to incur that cost of 100 cedis before you even think about producing the pants. So is that giving you a bit of a knowledge that these are becoming the fixed costs that have got to be incurred? Okay, those are the fixed costs that have got to be incurred before you start everything. But that's not all. Manufacturing also requires the amount of cloth and labor shown below. So let's go to that. So when you look at this section here, okay, when you look at the section that is right here in this labor hours, those are resource requirements. Okay, those are the requirements of resources that are needed. So you need this particular kind of labor, okay, to be able to what? To be able to do anything that you want to. So you need labor hours to be able to produce, okay, those particular variables. So this means that before I can produce shirts, I need 3 hours of labor and then 4 years of cloth before I can produce short. So these are the resources, the constraints. So you have the cloth constraint here, and then you have the labor constraint also there. So keep that in mind. Let's go back. And you are told that each week 150 hours of labor, 160 hours of cloth are available. So these are the right-hand side of the constraint. But there's something else. The variable unit cost. Watch that word. The variable unit cost. What is that? It is talking about the variable cost and the selling price. The selling price for each clothing are shown below. So when you go to the below here, the revenue section, okay, you have the sales price. And then you also have the variable cost. And you can see that the sales price depends on the level of production. So the shirt produced, and the level of production. And then this one, the variable cost also depends on the level of production. That is the cost you incur for producing more or less. Okay, now the simple situation is this. Formulate an integer linear programming model that will maximize profit. Tema Textile Limited weekly profit. Now, this is it. This is an integer linear programming You're going to formulate it and you're not going to solve it. The key is your ability to formulate it. And there's a skill, there's a trick of doing this beautifully. It appears to be loaded, but believe me, it's not that loaded. First thing to do is to write your objective function after defining your decision variable. So let's go and define our decision variable. So remember this principle of cost. Remember the total revenue that I indicated here? Don't forget that. I'll tell you the content of the total revenue and the total cost pretty soon. For now, let's define our decision variable. Let's what? How many of the x's do you think we have here? How many of the x's do we have? We have x1. Somebody has written the answer. We don't have 2 of the x's. We don't have 4. Let's go back to the story. The way you guys are saying 4, 2, and all of that, let's go back. Based on this, how many decision variables do we have? How many decision variables? I mean, if you look at it carefully, this is 3. It's shirts, shorts, pants. Let's keep that in mind. Okay, let's keep that in mind. Okay, so we have, so this is going to be shirts, this is going to be shorts, this is going to be pants. But look at it. Okay, if you look at the sentences, we need to know. There is a phrase that the manufacturer of each type of clothing requires blah, 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 has a suitable type of machinery. Okay. And watch it, the machinery needed to produce each type of clothing must be rented. And then you are told here, okay, you are told here, where is that? 3 hours of labor is needed to produce shirts. So the number of shirts is a possibility. Okay, so this is not something that we're expecting it to be decimals. We are not expecting shirts to be decimals, shorts to be decimals, no. So we can talk about the number of them, okay? We are expecting them to be whole numbers. We're expecting them to be whole numbers. There's no problem at all, not expecting them to be whole numbers. So the way you are going to formulate the objective function here is going to be X1 is the number of shirts produced. Okay, the number of shirts that are what? That are produced. And then of course they are produced every week. So you remember that. Okay. And then the second one is going to be the number of shorts produced, and then the number of pants produced. Okay, so that is how you're going to define the decision variables right there. There's no problem with this. However, there was a clause, and it's very important to appreciate that clause. It says that the machinery needed to produce each type of clothing must be rented. So it means that you cannot produce shirts, and you want to pay attention here. You cannot produce shirts unless you have the shirt machinery bought. You cannot produce pants unless you have the pants machinery bought, because that's what you're going to use to do the production. However, you will only buy a shirt machinery if you know you are going to produce shirts. In other words, if I know I'm not going to produce shirts, why will I go ahead and buy 200 CDs every week for shirt machinery? So you can see that there is something we need to do for this. We need to get something, we need to decide on whether we are going to buy the shirt machinery or not. So we have another decision variable to deal with. We have another decision variable to decide whether to buy or rent, okay, or to rent a particular shirt machinery. And so these machineries have to be incorporated as decisions. And they are very important for such incorporation. So how do you incorporate these ones as decisions? How do you do that? The key point is this. The cost of renting any particular machinery would depend only on the type of clothes. It's not on the amount of each type of clothing. It's not like I need to know how many number of shirts I'm going to buy, produce before I know whether to buy shirt machinery. No. It's about I'm going to produce shirts, and so I'm going to buy shirt machinery. So this thing is either it is there or it's not there. It's either the machinery is there, because as long as the machinery is there, as far as the number of shirts I'm going to produce is concerned, doesn't matter. So those particular machinery rentals, they do not depend on the amount of the clothing type. So how do you formulate this? So we're going to let Y represent each type of the machinery. So Y1 will represent the shirts machinery. Okay, and we are going to define Y1 to be there. So Y1 is going to be there, which is 1. Okay, if shirts are going to be produced, if any shirt at all is going to be, so it's going to be 1 if, okay, if any shirt, let me write it that way, any shirt is produced. In other words, if any shirt is produced, then the cost of machinery for shirt, Y1, is going to be there. The 1 here is referring to it being there. And then, of course, it's not going to be there, which is it's going to be 0 if no shirt is going to be produced. So we can say 0 otherwise. It's going to be 0 otherwise. That is if no shirt will be produced. Now, the same way, Y2 is going to be there if shorts, any shorts is produced. If any short is produced. And it's not going to be there. You're not going to incur that Y2 if no shirt is going to be produced. So 0 otherwise. I'm writing this for a reason, so that's what I wanted to write. And Y3 is going to be 1 available, that's there. If any pant is produced. And if eventually no pant is produced, then it's not going to be there. So it's 0 otherwise. So these are other decision variables that we've got to decide in this arena. So we have to decide whether we are going to buy this machinery, and then we also have to decide the number of the item, the clothes that we are going to buy, we are going to produce. Okay. So those are the various kinds of decision variables that are there. So just let me give you some scenario. If any of the x's, if any one of the x's, okay, is going to be produced. Oops. Let me just go back. If any one of the x's, okay, is going to be produced, and if I'm going to produce them, then I'm not expecting them to be 0, so it's not going to be greater or equal to 0. I'm going to be producing them, so it's greater than 0. If I'm going to produce any of the shirts or pants, okay, let me do it xj, so that it can be any of them, shirts, short pants. If any of them is going to be produced, that is greater than 0. Then I'm expecting yj, which is the machinery cost for that item, to be what? To be equal to 1, isn't it? In other words, I'm expecting that particular machinery to be there. And of course, what it means is that if I'm not going to produce any one of these, if it's going to be 0, then I'm not going to also incur any particular machinery cost for that. So that one will also be what? 0. This is the principle that we are going to adopt. So keep that in mind. With that in mind, let's go back to our objective function. How do we define our decision variables? What about the objective function? Well, to be honest, the objective function is very clear from the story that we were given. Before we do the objective function, understand that this is a profit situation that we're looking at. Someone says that why not x1, x2, x3, but xj? Oh no, the xj can be x1, x2. I just didn't want to write all of them. I didn't want to write, let me take you back here. Okay, I didn't want to write if x1, x2, x3 is greater than 0, then y1, y2, y3 is equal to, it to be too much. So I just didn't want to write all. Okay, I just didn't want to write all. That is all. So let me just write. Somebody is telling me to repeat that. So let me just write it slightly for you. So what I'm saying is that if x1 is going to be greater than 0, what does it mean when x1 is going to be greater than 0? What it means is I'm going to produce shirts. Remember, x1 is shirt, isn't it? If I'm going to produce shirt, then I need to have bought the machinery for shirt. And that is y1. So it means I need to say then y1 should be what? Equal to 1. Now, why is y1 not greater than 0 by its 1? Because y1 is either there or not there. We've already said that. So y1 is a binary, is 0 or 1. Is 0 or 1. I either incur the cost of machinery or I don't get the cost of it. I'm not going to decide on the number of machinery here. Okay? So it's a binary. And it's binary because I will only get it there provided I'm going to actually produce the shirt. It depends on the shirt. It's contingent on the shirt. Now, the same way, if x2, which is the pan, a short, if I'm going to produce it, that's how you write it. If I'm going to produce it, then I can say that I will incur its machinery cost. And the machinery cost is y2. So y2 must be what? 1. And the same way, if x3, this time I'm going to trick it. If x3 is 0, it means I'm not going to produce pants. Okay, if x3 is 0, I'm not going to produce pants. So then what? Then y3 will be what? It will not be 1 anymore. It will be 0 because I don't need y3 because I'm not going to produce pants. So why do I need pant machinery? So you only incur the pant machinery cost, the y to be 1, provided you are going to even produce a positive value of the x's. Okay, I think you understand now. Okay, so now with this in mind, let's go and formulate our profitability function. Remember the profit, which is the z. Okay, I just want to write profit from economics point of view first. Okay? I can just say profit max, which is the same as the z max. And we know that profit is the total revenue minus the total cost, don't we? Don't we? Okay. Now, what do you think is the total revenue? Total revenue is actually price times quantity, isn't it? Total revenue is a price times quantity. That's a per unit price and then the available quantity. Now, please remember here, our quantities are represented by x1, x2, x3, and so forth. Okay, those are the quantity, not Q. Yeah. And then you have the total cost. And I already told you that the total cost is what? It is the fixed cost or the fixed charge plus the variable cost. Do you remember that? It's a fixed charge, fixed cost plus variable cost. So in principle, we just need to find our total revenue, which is the price and quantity. Now, the question you got to remember and ask yourself is that this was all given in the storyline. So let's go to our story. This is our story. We were told that the revenue section here, okay, this revenue section, there is a price for the sales, which is what we just had, price times quantity. And we now know the prices for shirt. We know the price for short, we know the price for pants. So these are known already. So you just multiply by the excess, which is the quantity. And so when you go back to our analysis, let me bring it down here. So it's going to be the price times each quantity. And the prices were 12, 8, and 15. Okay, 12. Let me just show you again, because sometimes you need to see it with the eye. 12, 8, and 15. So that's why we are going to put it into the price here. So you're going to get 12 x1 plus 8 x2 plus 15 x3. So this is the price times quantity that we have on the revenue side. And then according to the formulation, we should have minus the fixed cost. Now the fixed cost are the y's multiplied by their machinery storyline. Okay, the y's multiplied by this. So ideally, these 200 would have been the fixed cost for shirts. But then we said that it is a machinery cost, and that machinery can be y can be 1 or 0. So y1 can be 1 or 0. Y2 can be 1 or 0. Y3 can be 1 or 0. So we got to take the 200 and multiply it by the y. Now, if y1 is 1, okay, let me just write it here, okay? Because sometimes when you're seeing it with your eye, if y1 is 1, okay, so you have y1 is 1. Okay? So it means that this 200 multiplying the y1 will be what? Will be come back to 200. That's what I mean. Because y1 is 1, so you get 200 times 1, and that will give you 200. So we now back to the proper fixed cost. But the thing is that we don't know whether we'll produce that y1 or not. So we have to know. So if we're going to produce it, it can also be 0, which means we are not producing it. And so the value can be 1 or 0. If it is 0, then we didn't get any 200. But when you multiply 0 by 200, it is 0. So now that decision variable, that fixed cost there is going to be the 200 y1. And then the other one will be the 150 y2. And the other one will be 100 y3. So they should be captured inside the the particular decision objective function that you are formulating. So let's go to the objective function here. So in this objective function, we're going to capture that. We're going to capture minus, and I want to bring it into a bracket just so that you agree with it. Minus 200 y1 plus 150 y2 plus 100 y3. So those are the various, fixed costs. And again, don't be so confused about what is this y1, what is this y2. We've already known where they are coming from. They are just representing something that is there or is not there. If it is there, it's 1. So you consider them as 1 or 0. If it's not there, it's 0. Then we are back to our numbers. Okay. Then there's a variable cost part. Watch it here. There's the variable cost part. The variable cost should be captured. So you have minus the variable cost. The variable cost here means it depends on the excess, the level of production. Okay. And they were actually given in the table. Go to the table here. See this section, variable cost here. Yeah, that's it. Okay, so you have 6, 4, 8. And they are all being multiplied by the excess. Okay, they are all being multiplied by the excess. So you have to capture them also with the excess in mind. So let's capture this. Okay, 6, 4, 8. So when you go to the formulation, you're going to have 6 x1 plus 4 x2 plus 8 x3. So all of these are inside what? The objective function. But hey, we know what they mean. This is not a secret. This is beautiful. We know where they are coming from. We are not afraid of it because we brought it. We did it. We negotiated it. So let's do an equality and find the final formulation. Somebody said, why not add all the variable cost to the fixed cost? Now, the reason is because the variable cost is, if you look at it, the variable cost is actually multiplied by the amount you are going to produce, the short, and the pant. And then the fixed costs are having different variables, the y's, and the y's. So you can't multiply them. You can't just multiply like terms with unlike terms. Okay, so one is x's, one is y's. You can't multiply, you can't add them. You can't add them. So what we are going to do now is to separate them. Okay, so at this stage, you will take the minus and run it through all of them. So please don't forget they are all going to be minuses here. Then you take the minus here too and run it through all of them. So don't forget it's going to be minus. So in principle, you are going to, this is going to be minus 6x1, minus 4x2, minus 8x3. That's how it's going to be. Okay. And then you can see that they are like terms, isn't it? You can see the 12x1 and then the 6x1. They are like terms. They are like terms. Okay. So you can subtract. I know somebody is going to ask me later, how did I get my answer? So please, I want you to check. I'm going to take the x1s minus each one of this, the x2 minus each one of this, the x3 minus each one of this. I'm going to do 12 minus 6. That will give me 6x1. I want you to follow me before I finish. And then somebody will ask me, how did I get it? Okay, so 12 minus 6, because each one of them will be multiplied by minuses here. Now we have 8 minus 4, 8x2 minus 4x2. So that will give you plus 4x2. And then look at the 15. It is 15x3, and then there's x3 here, so that's minus 8x3. Minus is in front of the bracket, don't forget that. So that will give you plus 7 7x3. So I've been able to take care of all the x's. I'm now left with the minuses for this. I'm left with that. So those are not like 10, so I have to leave them like that. So I must have minus 200 by 1 minus 150 by 2 minus 100 by 3. So finally, this is our Z max. This is our pi max or our Z max. Anyone is fine. Okay. Now, Isaac, you have a question? So I'm just going to allow you to ask your question. So Isaac, ask your question.
Okay, Doc, I got quite confused when we got to where we have the fixed cost plus the variable cost. I thought we'd be having the 200y1 plus 150y2 plus 100y3. The next bracket was going to be an addition because they are together, but I saw the minus, so I was quite confused about that.
Oh, you don't have to be confused. The only thing is I could have put it all into the bracket, but they are all going to be multiplied by minus anyway, isn't it? The minus is outside the bracket. So all of them are going, if you look at the top here, fixed cost plus variable cost, all of them are going to be minuses anyway. So I just decided to bring the minus in front just to capture it.
Oh, okay.
Yeah, it's just mathematical equation. If you know the thing is going to be minus already, no matter what, everything in the bracket is going to be minus. And you can see that eventually everything has been minus.
Okay, the reason why I was asking was that you see the 12x1 plus 8x2 plus 15x3, they are not behind the equal sign.
They are
not before the equal sign. So if you're subtracting, I thought that there should be an equal sign between that will allow us to do the subtraction as you have done. Would you get in the 6x1 plus 4x2 plus 7x3?
And it will get the same thing, isn't it? That's what you're saying.
Yes, please.
If we will get the same thing, then don't worry. Maybe you are talking about something that will lead to the same thing. So don't worry. Okay, we all agree. Eventually we'll get the same thing. That's okay.
Okay.
I have another person with another hand. Let me see who. Felicity. Felicity, ask a question.
Hello, sir. Please, I thought we were supposed to multiply the 12x1 8 plus 8x2 plus 15x3 by the ones in the bracket.
Does it look here that you are multiplying or you are subtracting? Look at the top. At the top. Does it look to you that?
Okay. So, sir, please, does it mean there's 6, 4, and then 8 are not in the bracket?
They are in a bracket. They are in a bracket. I mean, come on. I went through this with you and I said, I hope nobody is going to really be worried about what I'm doing. And you are still worried. What is really your question? Because see, from the top, you don't need to be, if you are confused about everything, not this one. Because this is the last thing you want to be confused about. Okay. Look at this section here. Do you see what I've underlined? Let me go back.
Yes, please.
Okay. Now, look at this section here.
Okay.
Okay, I'm not even sharing the screen. That's why.
Okay.
Okay. I've underlined the PQ minus FC. Have
Yes,
you seen
please.
that? Now,
Yes,
if you look at it, the minus, is it not multiplying the FC and the VC?
Please, it is.
Okay, so it means that everything in that bracket is eventually going to be minus, isn't it?
Yes, please.
So if I bring the minus in front of the first part and I bring the minus in front of the second part.
I understand, but
That's what?
I thought, okay, I get it now. I thought because they are in the brackets, automatically we are going to multiply.
You're going to multiply what and what? Let me know. Multiplying what and what?
Multiply the PQ by the VC.
Oh, my dear, mathematics then I watch that if you have 3 minus 8, I didn't like 3 minus 4 plus 2. Okay, if you have 3 minus 4 plus 2, you say that because the 4 plus 2 is in a bracket, we are multiplying 3 times 4.
Oh, I get it. I get it.
Hey, masters. That's still because you have to ask questions into
so we are subtracting 3 from 2. I get it now. It's clearer this way. Thank you.
Hey, mommy. Daniel Gaius. Let's go to Daniel Gaius. I mean, I wasn't expecting this one should be there because this one is a class 3, 4, class 4 for maths. Yes, Gaius.
Sir, my colleague says that there should be an equals to. That's not what that should be. You know, is the minus is the total revenue minus the fixed cost, and the total revenue is the price times quantity. And minus the total cost. Sorry, and minus the total cost is into brackets the fixed cost plus variable cost. So this the x, the y, the y's, and the x's that we have put. Is there, if you want, like, to have even expand the line and put the x also into the brackets, and then you open it, and the negative will affect the x's and also affect the y's.
All of them, wouldn't it?
Or to affect, it won't be an equal, because any sign, if anytime that there's an equal sign, and you take any value across the equal sign, whether positive or negative,
any value across. Master, we haven't taken any value across anywhere.
Sir, my colleague was saying that there should be an equal sign, and you say yes. And that one, the student have been an equal sign. The negative is okay.
Well,
sir, I don't know whether you are getting me.
I'm not getting you,
sir.
I'm not getting him. Provided you guys can get each other, that's okay. I don't see, yeah. I'm not expecting this to be a problem because this is equation. Eventually,
it's not a problem.
Eventually, I could have stopped everything and brought this whole thing in a bracket. I can't go.
Yes.
So I decided to bring the minus. You understand? Once you understand and everybody understands, that's okay. That's okay.
Okay.
At the end of the day, it's not about the procedure that is the final answer.
Yes, sir.
Unless you guys don't understand like terms and unlike terms.
So it's perfect.
What do you call it? Isaac. I just hope that you're not coming to confuse the rest. So ask your question. Because this is a very simple equation.
Oh, okay, Doc.
I need to go and take class 1 to show her.
Hello, Doc. I think the understanding is now clear here. I think with the grouping of like and...
You wanted me to repeat, not because there was a problem.
No, Doc, it's because of how the bracket was brought below it, so it was kind of confused. I understand that you group like and you subtracted it.
Yeah. I'm saying that even if the bracket has been brought differently, still, you guys know it.
I get it. I get it because of the arrangement. That's why I got
it. For me, instead of, you see, once you guys ask certain questions, it confuses other people. So what you guys are saying I should do, which I thought that is I could have done, but because it's long sentence, okay? Yeah. This is what you guys, it's simple. You guys didn't understand the general thing. So for me, it's best that I explain the general thing for you, not the mathematics here. Because the mathematics here are so simple, so easy, nobody should have, let me just delete this. Okay. Nobody should have a problem with the mathematics. You are just probably having a problem with the fixed cost, variable cost, and those things that are there.
No.
This is what you guys, but once you understand that, once you understand those fixed costs, variable costs, okay, the rest here is just addition. Let me just go back and show you.
Okay,
I mean, this shouldn't have been difficult at all to explain, because anybody who is in class 1 will know that this is 12x1. You want me to just repeat it? That's all. Plus 8x2 plus 15x3. Okay. Now I'm going to apply minus to everybody. So I do minus 200y1 minus 150y2 minus 100y3 minus 6x1 minus 4x2 minus 8x3, isn't it? That's it. Okay, let me just unmute you. Okay, because you see what we have there, this one is taking long, and I was expecting that this one shouldn't take long, because what we have there is more difficult. Okay, and let me just unmute you, because this one, dear, I'm so.
Hello.
Hello. Yes, ask your question.
Okay, so with me, I'm okay. I'm okay.
Then don't talk. I want those who are not still up. So what I've just written down here, that's all that was here. Okay, that Abdul guy, he was explaining it nicely that because he can't go here, I decided to create another bracket and just continue them in the plus. But you see, when you look at it from this angle, when you just look at it from this angle here, there's a minus which is multiplying the fixed cost plus the variable cost. So if I should apply the minus in between here, they'll all be minus. You should understand that the fixed cost plus the variable cost is the total cost. The total cost is the fixed cost plus the variable cost. And then everything becomes minus. That everything becoming minus is not a problem. Then I also indicated that I'm going to take the like terms, because they're all having XX. I'm going to subtract the XS and leave the YY. That one too was our hala. Anyway, let's continue. Since you all get it now, let me rewrite the whole thing properly. Okay, the whole thing now. My delay is some 15 minutes that I wasn't expecting our delay. 12 minus the 6x1 will give you 6x1 plus 4x2. When the things are going plenty like that, 7x3. But all you should say is but not this one should have been this. This one should have been this. This one should have been this. Yeah. Classes. A Nieman or say may multiply. Why would I multiply it? So this is how it's supposed to be. Okay. And then this is it. Now, but you see, when you look at this thing like that, it's so confusing to your eyes. Now you want to know where it's coming from now. And that is why some of you had to take us back to where it's coming from. But honestly, go back and look through it, because now that we've delayed there, okay, what it means is that and then it'll be essential. It is minus 100y3. And I've written minus 100y3. Augustine, why do you say it is minus 100y3? The 100 is there. The minus is there.
So it's not 100, it's 00y3.
It's not 00y3. It is minus 100. It's just my first right. Which is a good baby. Hey.
No.
You and I both, the guy is writing minus 100, but the minus, one has entered into the minus. It doesn't mean it's plus. I mean, you should know it more. It's like, we're confused. Everybody has to be confused.
Doug.
Yes.
Pacho, please, in the bracket here, I saw fixed cost plus variable cost. Now, when you open it under here, you made it minus. Why is
It doesn't matter. Don't worry.
Okay.
Whichever way you think about it, okay? Whichever way you think about it, you analyze it. Go and put it all into the bracket. Don't take my minus. Take yours the way you want it to be. Eventually, you'll get the same thing.
Okay.
Eventually, you get the same thing. I mean, this one. They need to even drink double of that one. Yeah. Now, with classes, when you expand that the brackets now are all out, that the whole thing becomes minus. Classes, yeah, expansion and factorization. Now, my bracket, obi tea pie not to say cocaine one. Let's continue. Let's continue. I'm going to mute everybody and then we can start. Okay. All right, so let's continue. Now we are going to go through the constraints. All right, so what I'm going to do is I'm going to rewrite the whole formulation here, the constraint, the linking constraint. So you have x1, okay, less or equal to x1 less or equal to m1 y1, and then x2 less or equal to m2 y2, then x3 less or equal to m3 y3. And then I indicated that we have our constraints. So I just want to go and then indicate the constraint again, because if you can remember, there was a constraint that we have. So I'm going to rewrite the constraint. The constraint was 3x1 plus 2x2 plus 6x3 less or equal to 150. Okay. And then 4x1 plus 3x2 plus 4x3 less or equal to 160. So that was our constraint. And the goal was to find M1, M2, M3. That was the goal. Okay. So where do we find the M1, M2, M3? We indicated that to find M1, M2, M3, you make an assumption. Okay. You assume, so we want to find M1 first. So we indicated that to get M1, okay, you assume that X1 and then X2 and then X3 are 0. So we are going to find X1. And the reason why we are going to find X1 is because M1 is the highest value X1 can take. Okay. So how do we find X1 inside this constraint? Well, we have to assume that this X2 and X3 are 0. Okay. So if you are 0, if this is 0 and this is 0, it means that we are left with 3x1. So we're going to have 3x1 equal to 150, which means that x1 is equal to 50. That's what we said. Okay, and then you come to the second constraint. So in the second constraint, you're going to assume that the x2 and x3 are 0. Okay, so if x2 and x3 are 0, we are left with 4x1 equal to 160, which means that x1 is equal to 40. And so on the basis of this, we indicated that which one are you using? You're going to take the smaller x, and therefore our M1 is going to be 40. Now, why take the smaller x? Well, we take the smaller x because you want the highest value x1 can take. We want the highest value the x1 can take. Because the x1 must take a higher value because you have already incurred a cost. And so if you already incurred a cost, you need the highest value to produce. You need to produce as much as you can, okay? Because you've already indicated that. So the M1 should be set to the maximum value that X1 can attain. Okay? And in this context, the 40X or the 40 shirts can be produced if the company produce more than 40 shirts, the company will run out of cloth. That's what it means. They'll run out of cloth. And so because you don't want them to run out of cloth, you can safely choose M1 to be equal to 40. And that was a principle that we were indicating right there. So somebody was asking why we did that. That was the reason why we did that. Okay. So now let's find M2. Now to get M2, okay, so I'm going to write that to get M2, what it means is that the X1 and then the X3 must be 0 so that we can find X2. Okay, so it means that the first term in the constraint here must be 0, and then the second term must not be 0, and then the third term must be 0. So if we have second term is not 0, it means you are left with 2X2 equals to 150, which means that X2 is equal to 75. Okay. Now, when you go to the second constraint, in the second constraint, watch it carefully. We want the 3X2 to stay. Everything else will be 0. And if they are 0, the numbers attached to them are 0. So we'll be left with what? 3X2 equal to 160, which means that X2 is 53.33. And then again, we'll choose a smaller one. So M2 is going to be the smaller X, and that is 53.33. Now let's go to the third one, M3. M3. We said that to get M3, we need to set X1 and then X2 to 0, so that whatever we see X3, we'll work with that. So in the first constraint, when you set the first two to be 0, you'll be left with 6X3 equal to 150, which means that X3 is equal to 150 divided by 6. What value is that? 150 divided by 6. Yeah, who's going to help me with the final answer? 150 divided by 6? 25. Okay, so you get 25. And then we go to the second constraint. If you set everything to 0 except X3, you get 4X3 equal to 160, which means that X3 is what? 40. And so once again, we choose a smaller one. So M3 will be the smaller one, which is 25. So it was on the basis of this that we were able to get. So our first M1 was, okay, our first M1 was 40. Our M2 is 53.3. Our M3 is 25. And so we are just going to substitute them into their values here. Okay, we're going to substitute them into their values. And so we rewrite the whole thing by substituting that. Okay, you have 40, you have 53.3, and you have 25. So the first one will be X1. Let me use a different color that will make it a bit more caption. Okay. So you have X1 less or equal to 40 Y1. And then X2 less or equal to 53.33. Okay, Y2. Then X3 will be equal to less or equal to 25 Y3. So you add this one to the constraint that we had before. Okay. So when you go to that constraint that we had before, let me just show you. You will see that they are all added together. So now you have the cloth constraint, the labor constraint, the linking constraint, which connected these things because you were able to get the ends from these values. Okay, you get the ends from these values, so you link them beautifully like that. And then finally, you have your usual non-negativity constraints, the usual integrality constraint, and then the binary constraint. Okay. So you have all of this, and this is it. This is the formulation that we had, and this is the final formulation. This is all you need to do. You can work it out in Excellent. Now here you can move the right hand side to the left hand side, so that will be left with zeros for each of these three linking constraints, which means that the values should be negative when it goes to the left hand side like this. And then you can work this in Excel. When you work it in Excel, you're going to get X3 to be 25, Y3 to be 1, which makes sense because now you are incurring a plant machinery cost. Y3 is equal to 1. And that is why you are producing 25 pounds. When you substitute these into the objective function, okay, everything else is 0 except Y1, Y3 is 1, and X3 is 25. That will give you a Z value of 25. So what it means that if we make any shirt at all, okay, no matter how many shirts we make, okay, in fact, it should be pants. Okay, if we make any pants at all, no matter how many pants we make, we must pay a fixed charge of this amount to rent the pant machinery. Okay, that is it. Okay, so you have to just watch the values and then be able. But what this means is that we don't have to bother ourselves dealing with shirt or short. Everything has to be put into pants because that is the X3 that we have to deal with. If you check in Excel, you get this beautiful thing that I've done there in Excel. You can look at it and then you can solve it also on your own. Okay? And then this will give you the final result as we have done. So this is what we call a fixed charge. A fixed charge allows you to bring the principles of economics into an integer linear programming model. Now, if this was in an exam, I would just give you the whole thing to formulate. I will not let you solve, but you got to get the skills. And the key details of this formulation hinges on you finding the M1. Now, watch it. The M, okay, there were 3 constraints. There were 3 decision variables. Okay, there were 3 decision variables. That's why we dealt with 3 M's. If there are 4 decision variables, okay, we're going to deal with 4 M's. And of course, even though we are dealing with 3 M's, we could have had more constraints. We could have had another constraint. Suppose we had 2 more constraints, labor, cloth, water, or something. Okay, if we had another more constraint, we would have also put that into the constraint. So we solve more constraints to get the smallest value and dealt with it. Either way, it doesn't matter. The key point is understanding the principles of how to execute it. So this value means that we need to produce 25 pounds whilst incurring a 100 pound machinery cost. Whilst incurring a 100 pound machinery cost, not shirt, as it was indicated earlier. Okay. Fantastic.